Hi guys, and welcome back to our second video in the Module 6 Acid and Base Reactions. Today we're just going to quickly touch on, again, something that you had completed at home during the holidays and again have done already in your junior schooling, is to conduct an investigation to demonstrate the preparation and the use of indicators as illustrators of the characteristics and properties of acids and bases and their reversible reactions. So again, let's look at that outcome. We're conducting an investigation and looking at how we can make them and how they're useful to determine whether a substance is an acid or a base. And then we're bringing in that word reversible reactions again from our Module 5. So what is an indicator? So these indicators that we use are plant-based indicators that change colours in a variety of different substances. So many of them, and you may have used one of these at home, are used such as red cabbage, red coloured flowers, blueberries, red grapes, any other strong coloured plant-based substance will usually work. Some of them better than others that you may have found out over the holidays. So what happens with these is these indicators change a different colour in the presence of an acid or in the presence of a base. So if we have a look here, you would have used indicators in class before and you would have noticed a couple of different indicators. We might have had litmus that really only just told you whether it was an acid or whether it was a base. You've also used universal indicator, which is a mix of different indicators so that it gives that full range of acid through strong acid through to weak acid through to weak base and strong base, and gives us that whole range that you would normally see with those characteristic rainbow type colours. And other indicators will give totally different reactions depending on the substance that it is. So with our universal indicator that you would have used before, you would notice that we usually have a value between 0 or 1 through to about 14. So our acidic solutions are those that have a pH less than 7, and we'll come to pH and what that means a little bit later in this module. Neutral solutions have that pH of 7, and the basic solutions have the pH greater than 7. So if we look at this equation that we have here on our board, and this may be bringing back some good or bad memories of Module 5, we're looking at it's an equilibrium reaction that's taking place. So here we have our indicator over here, and often it'll be our reddish solution if we say that there's acid in there, and the reversible reaction is then with our H+ with our indicator. Now, if I was to add some acid to this solution, we know that an acid ionizes and breaks down into its H+ ions, so we would be increasing here this H+. So think back to Le Chatelier's, and when we're increasing the concentration here of H+ by adding some more acid to the solution, it's going to increase in concentration. Now, as Le Chatelier said, that when there's a stressor placed on the system or an increase in concentration, in this case, the reaction's going to try and reverse the effects of that addition. So the way it's going to do this is by shifting to the left to produce more of this. So we're going to get more of that red colour, say. If I was to now add some sodium hydroxide to the solution, what I'm actually doing now is decreasing this concentration of H+. So by decreasing this concentration of H+, the system is going to try and counteract that change by coming this way and producing more of this indicator, which in this case is a blue colour. If I then add a little bit more acid, again, it's going to try and counteract that change, and we may end up neutralizing the solution, in which case we would get that neutral color. Some indicators you may find are better than others, and we're going to look at a range of those in class. Some indicators, so if you used the red cabbage, you may have found that when you tested it in a variety of different substances, you got a variety of different colors, whereas some indicators may just indicate that it's acidic or it's basic. So we'll discuss that a little bit more in class. But you will see also when we get into using a variety of indicators in the classroom, for example, phenolphthalein, it will be colourless and then go to a bright pink. But there's no difference really between them. So it's hard to tell when it goes from being acidic to being basic. Methyl orange has a different range of pHs that it works well in. So when we're using indicators, often it's good to know in advance what type of reaction we might be doing, where a pH change might be, to choose the best indicator for the prac that we're going to be doing. But we'll touch on that a bit more, or a lot more, a bit later in this unit. Thanks.